for number 5, we actually did solve it already up here. So the angle in example 4 was 4.30, and again we had to be considered of theta 1 and theta 2. We needed our calculator because it was not a special angle. We need our calculator to go from the ratio to the angle. So this one here, we are looking at the coordinate in quadrant 3 is negative p, positive q. Now when you draw this, make sure you don't draw it at 90 degrees, or sorry, it's 45 degrees, because drawing it at 45 degrees implies a symmetry which may not exist. So the diagram may end up being misleading if you do that. So we always try not to imply symmetry when we don't know that it exists, or when we're generalizing something. So find the primary trig ratios. I'm just going to square, so I get p squared plus q squared. Okay, and to find the primary trig ratios, I'm just going to say sine theta. Sine is y, so negative q over p squared plus q squared. The cosine is x, so negative p over square root p squared plus q squared. And then the tan, it's a slope, so it's going to be negative q over negative p, so it's just going to be positive slope there. Okay, so those are the primary trig ratios. I need to locate the position, I need to find the hypotenuse and relate sine to y, cos to x, and slope to tan. Now, to do this problem here, we have to kind of visualize, well, here is the theta. Okay, here's theta that I'm talking about. Well, I don't know exactly what that angle is because we generalized it. And I have to figure out where is that going to look? Where is it going to be if I start at 2 pi and go backwards the same amount? Okay, so I went through one quadrant, 2 quadrants, and that amount through the 3rd quadrant. So if I were to go backwards from pi over 2, so here's 2 pi. If I go backwards from 2 pi the same amount, I'm going to go through the first 2 quadrants and end up here. Okay, and in fact, it's going to be symmetrical to that bottom triangle. Okay, so the positioning, that's what I really want. Cosine's positioning. I really want the positioning, and the positioning is going to be based on the symmetry to that point there. In fact, that is the formula for the cosine ratio when we talk about theta 2. Remember that it's going one way, the x-coordinates are the same going in both directions. So if I want to find the cosine of that, well, I just look at that picture. That position is negative p. The radius is still the same. Okay, there it is. There's my cosine ratio. Down the road when we get into trig identities, there's actually a formula for this, but we don't necessarily need a formula. We can just work this out geometrically. The last one here is tan, and it's 90-degree rotation. So when we rotate things 90 degrees, I think we may have talked about this before, but when we rotate things in 90 degrees, okay, I'm just going to call that AB. That position over here, 90 degrees around, is going to be negative B, positive A, because notice that the triangles formed are the exact same triangles. Okay, that's going to be B this way, so it's going to be B this way. And that's the same thing that's going to happen when we keep rotating. We just switch x and y's, and one of them becomes the opposite sign. So this becomes positive B, negative A. Okay, so these are what happens with 90-degree rotations. Essentially, the x and y switch, and we get the other. It's a negative, what we call the negative reciprocal. So when I rotate the slope 90 degrees, I should get the negative reciprocal. So let's just verify. Let's check that in our diagram here. So I'm just going to get rid of some of this here. There's my theta. I'm going to take that theta and I'm going to move it 90 degrees like that. Yeah, I'm going to add 90 degrees here. That green position then represents theta plus pi over 2. Well, that triangle, yeah, that's still the same triangle. It's going to go negative p down. It's going to now, instead of going negative q, it's going to go positive q this way. So the slope then becomes, well, my vertical becomes horizontal, my horizontal becomes vertical, and then my slope ratio becomes negative p over q. So we end up with a negative reciprocal slope when we rotate 90 degrees.